Hi and welcome to part 2. Don't watch this part unless you've already watched the other video because this is the second part of the notes. So we're starting up on this page here. So we've already talked about finding the mean or the expected value and kind of like how it's found and what you need to write on the paper. The other part of this is the variance. Now we're going to get to the standard deviation, but first of all let's talk about the variance. So to find the variance, we're going to square the distance from the mean for each value. So again, we're going to find the distance from the mean for every value. We're going to square them so that we don't end up with any negative values, multiply by its probability, and then add the products. Okay, that's a mouthful. So in order to get the variance of x, that's going to be sigma squared, so that's the sigma of x squared, so that's your variance. You take each value, find its distance from the mean, so here you have x1 minus mu of x. We're going to square that and multiply by its probability. So we're finding all the deviations and squaring them and multiplying them by their probabilities. By the way, this kind of average taking where you multiply each number by its probability, it's the same kind of weighted average taking we do when we calculate grades, for instance. You would do your homework and classwork grade times 10%, or your quiz grade times 30%, and your test grade times 60%, or whatever the grade distribution is for your class, and then add up all the numbers. So if this seems familiar to you, that's probably why. So we have the squared deviations times their probabilities. Now again, if you wanted to write this more compactly in sigma notation, it looks like this. For each element x, you're going to find its distance from the mean, square it, multiply by its probability, and then add up all of those products. Now to find the standard deviation of that, we just have to take the square root. So just don't forget, once you're done with that, then you're going to find your standard deviation by taking the square root of that. Don't forget what a standard deviation is. And when you're interpreting this, it's a measure of how much the values of the variable tend to vary, on average, again, from the mean. So let's do an example of this. We're going to start with the mean. So on an American roulette wheel, there are 38 slots. 18 are red, 18 are black, and 2 are green. And I know you're probably familiar with this because we did have a question like this in the probability chapter. Suppose you place a simple $1 bet on red. That means if it lands in a red slot, you get your original dollar back, plus $1 for winning the bet. If the ball lands in a different colored slot, so not red, the player would lose your dollar bet. So let's define x. I'm going to let x here represent the gain, the net gain from a single $1 bet on red. So the possible values for x are losing your dollar or gaining a dollar net. I'm going to make a probability distribution over here. So x would be negative $1 or $1, and again the negative $1 is if you get something that's not red, and the $1 is if you get something that is red. The probability distribution also has to include the probabilities, of course, the probabilities of each of these outcomes. Well, the probability you get something that's red is going to be 18 out of 38 because there's 18 red slots out of 38 slots. So the probability of getting something that's not red is going to be 20 out of 38. So let's go ahead and compute and interpret the mean of the random variable here. So in order to find the mean, which is going to be your expected value, I would take each number and multiply by its probability. So here I'm going to take the negative 1, multiply by its probability, and the 1 and multiply by its probability, and then I'm going to add those numbers together. So here I'm showing my work. So negative $1 times 20 over 38 plus positive $1 times 18 over 38. And of course you do that in your calculator and you find that that equals negative 5 cents. So that's the compute part. Usually the part that people forget to do is the interpret part. So let's interpret that. So negative 5 cents. Remember, what x is your net gain from a single dollar bet on red. So a net gain of negative 5 cents means that you're not actually gaining. It means that in the long run you're going to be losing money. So an interpretation might look something like this. In the long run, a player loses, which means the casino gains, about 5 cents per bet. Again, in the long run, the house is always going to win. Otherwise, it would be a terrible business model to run a casino. All right, so for the one in the box, I want you to go ahead and pause the video and calculate and interpret the mean of the random variable x in the example on the previous page. So again, if you go back to the previous page and look at the NHL goals example from 0 to 9, calculate and interpret the mean. I'll be here when you get back. Hopefully you were able to do this. I don't expect you to write out all 10 terms. What I do expect you to do is to, similar to the chi-square test statistic, you're going to want to write out the calculation for the first 2 terms plus ... and then the last term. And then, of course, hopefully you should have gotten 2.851 goals. Now, the hard part is going to be the interpretation part, which is going to be, on average, the number of goals scored by a randomly selected team is 2.851 goals. Maybe that should have said the number of goals scored in a game or something like that. But on average, the number of goals scored in a game by a randomly selected team is 2.851 goals. Now, I did not do this by hand. I mean, I kind of wanted you guys to because I wanted to make sure you guys could, but I did not do this by hand. I'm going to show you how I actually did it in just a second. Let me show you what would be required for the work for the second part. Calculate and interpret the standard deviation. So the amount of work I'm going to show again is going to be the first 2 terms, ... and the last term. So it's going to look something like this. The variance for x is going to be equal to, and here I've shown the difference for the first term from the mean squared times its probability, plus the difference of the second term from the mean squared plus times its probability, plus ... and the last one, which is 9 goals minus the mean, which again we got the mean of course from the previous part up here, squared times its probability. And I got this lovely answer. Now again, the interpretation part is going to be something like, on average, the number of goals that's scored will differ from the mean by about 1.632 goals. Oh, because it's 1.632 because of course the standard deviation is going to be a square root of 2.665. So if I didn't do this by hand, how did I do this? I did not do it in my head. I did it using the calculator. Now remember, you have all these numbers in your calculator for a reason. It wasn't just to make a probability histogram because, I mean, let's be real, you don't really need to be able to do that because I gave it to you on the paper. To do this, I'm going to go back to good old one variable statistics. So I'm going to go to Stat, Calc, and the first option there says 1 var stats, 1 variable statistics. Don't be tempted to go to 2 variable statistics. We pretty much never use that. So 1 variable statistics. What list is your data in? Well, I put my list in L1. The frequency list, this is where it's going to be different. Typically you leave this blank because you're only interested in the stuff in list 1. I'm going to go ahead and then do list 2. That tells you the frequencies of each of the things in L1. By the way, if you're using an 83, your command is going to be 1 var stats L1, L2. And I'm going to go ahead and calculate. Now, the symbols here are not great. Because it's kind of a generic 1 var stats, they kind of use it for a bunch of things. They have not a mu here, but they have an x bar. I mean, we know that it's mu. We know that it's going to be the mean of this entire probability distribution, so we know that should be mu. But regardless, it is going to give you the mean, so 2.851 goals. So that's where I got that from. Now, if you look down here, you'll notice that the sum is also going to be the same thing. Remember how we get the mean in this case, is it's going to be the sum of each number times its frequency or times its probability. If you look down further, you're going to see sigma x, which is going to be the standard deviation. So 1.632 or thereabouts 1.63 would be your standard deviation here. If you wanted to, you could scroll down further and look at your 5-number summary. Not that it's that hard to find for this one because there's only 10 numbers. But if you wanted to find out where is the 25th percentile, that's going to be your first quartile. The 50th percentile would be 3, and so on. So, I hope it's clear how much work you're expected to show, and also how I actually do it on the calculator. If it's not clear, you might want to rewind and watch that part again just so you're clear. All right. Couple last things here. Are there any dangers to be aware of? Yes. First of all, to find this, don't forget you have to show work to get credit. Now again, writing your first 2 terms and the last term is just fine. But if you don't show any work, you don't get credit for magic on the AP Stat exam. You get credit for doing math and for showing math. Second of all, don't forget when you do this, you had to put in L2 here. Now, if you're using an 83, it's fine. But if you're using an 84, the next time you go to do one variable statistics, it'll default to whatever your last setting was. And now if you have a different list and you're not using a frequency list, you're going to want to clear that out. So either clear it out or change it back to 1. Again, if you're doing an 83, you don't have to worry about it so much. But for an 84, again, don't forget to clear that out, because if you just leave it the way it is, it's going to give you incorrect results. So change your frequency back to 1 or just clear it out. Either way would be okay. All right, and really briefly about continuous random variables. We talked more about continuous random variables in Chapter 2, although we didn't call it that. We called them density curves. And just a quick few things to remind you before we do our last example. If x is a continuous random variable, what is the probability that x is exactly equal to a? Well, let's think about what that means. If I have a continuous random variable and I'm interpreting area to be probability, the probability of having the exact value a is going to be 0 because a line has 0 area. So the probability that x is exactly equal to any particular value is going to be 0. Now, if I wanted to find an interval, so how is probability of x less than a related to x less than or equal to a? So if I wanted to think about the area between, whatever the minimum number is and a, that actually has an area, because now I have some width on the bottom of my little rectangle there on my very simple example. That actually has a number, but the area of the line itself is 0. So these two things are actually equivalent as far as continuous density curves or continuous random variables go. Since the value of x equal to a is 0, these two things will have the same value. Now, yes, technically speaking, these two aren't the same idea because one of them contains this value, one of them doesn't. Honestly, since most of the stuff we do in real life stat is approximate anyway, it really does not matter, and you don't have to worry about drawing it with a dotted line here for the a or anything like that. Now, you should be able to actually do the rest of this page by yourself because it is a review of Chapter 2, so go ahead and pause the video and finish the rest of this page and come back to check your answers. Okay, hopefully you actually checked your answers. So here we're dealing with a normal distribution with a mean of 30.7 and a standard deviation of 3.6. So I'm going to go ahead and write that down so that I don't have to go back and having to read that again. So I know that x is going to be approximately normal, what that mean in that standard deviation. Find the probability that the randomly selected 3-year-old female weighs at least 30 pounds. So if this is a multiple choice question, I'm writing a probability statement, drawing a sketch, and doing it on my calculator. So if this were a multiple choice question, I'd be writing a probability statement. The probability that x is greater than or equal to 30. That's at least 30. I'm going to draw a sketch. So I'm going to go ahead and draw a curve. Whoops, there we go. There's my curve, it's centered at 30.7, and I want to find the area greater than 30. And I'm going to do it on my calculator once I know that. So I'm going to do normal CDF with a lower bound of 30, an upper bound of positive infinity, or as close as my calculator gets, with this mean and this standard deviation. Now that's what I would do if it was a multiple choice question. Again, write a probability statement, draw a sketch, and do it on my calculator. And you don't have to write the calculator stuff on your paper. It's just to remind you in case you've forgotten how to use the calculator command. If this is a free response problem, you are of course going to show some work, which means changing those to z-scores. So at minimum, hopefully you want to show some calculation for how you calculate it. So if I change the x to a z, I'm going to take that number, subtract the mean, divide by the standard deviation, and then of course I'm going to get some z-score. Now at this point, you can also put it into the calculator if you're using the calculator. If you're using the table, don't forget your table gives you areas to the left. So if you look up negative 0.19 in the table, you're actually going to get the area to the left of that particular point here. So the area to the left, your table tells you, is 0.4247. So again, if you're using the table, you do 1 minus that number in order to get your answer. If you're using the table, you get a slightly different answer than this one, but again, if you're doing this in a free response, as long as you're showing your work, it doesn't really matter which one you have. If you're doing this as a multiple choice, the answers will not be so close that you can't tell which one it is. Most likely, in this case, they probably wouldn't have picked this exact value. They would have picked something that's the same to like 3 decimal places. For part B, same thing. Hopefully you wrote a probability statement, you drew a sketch, and you did this on your calculator. So your probability statement here in this case, x is between 25 and 35. You drew your sketch, hopefully. So you drew your curve, and then you drew some values, and of course you're going to shade that area in between. And you did this on your calculator. So I want to find lower bound 25, upper bound 35, with that particular mean and standard deviation, and hopefully you got an answer. Now again, if it's a free response problem, you need to show a little bit more work. You want to show how to change these to z-scores. So again, subtract the mean, divide by standard deviation. And of course, you're going to get some numbers for these things. Again, at this point, you could do it in the calculator using 0 and 1 for your mean and standard deviation, because again, your standard normal distribution has mean and standard deviation as 0 and 1, or you could do it on your table. If you're doing it on your table, don't forget you're going to look up both of these areas to the left, and you're going to subtract to find the difference. Again, as long as you show your work, you're okay. For part C, it's going to be slightly different. I want to know if we have some value so that it's at the 80th percentile. That's what that says there. So you want to draw a sketch. So here's your sketch. This is the 80th percentile, so hopefully you realize that your K is going to be somewhere to the right of this, because it's not going to be to the left. Again, it's going to be more than 50%. And I want to find some K so that the area to the left of it is going to be 80%. I want to know that it's at the 80th percentile. Now, if it's a multiple choice problem, you're probably drawing your sketch, and then you're going to go straight to your calculator. So I want to find the number that has an area to the left of 0.8. Using this mean and this standard deviation, you're going to get some number. But if it's a free response problem, you want to show some work. So you'd look this up on your table or on your calculator, and you'd say, okay, well, what z-score would it have if it's at the 80th percentile? The z-score at the 80th percentile is about 0.84, so it's a number that's 0.84 standard deviations above the mean. Now, if that makes sense to you in your head, it's 0.84 standard deviations above the mean. You can actually calculate directly from there. If you want to show some work, again, the way you get a z-score is going to be a number, subtract the mean, divide by standard deviation. We know the mean and standard deviation as well as a z-score, and then you're going to do some algebra in order to calculate what that number must be. Again, if this was a free response problem, you'd want to show some work. It's not likely, honestly, that you get this for a multiple choice problem because it's so simple, but if you did, there would only be one number that's close to these. It would probably be like 33.7 or something like that. Which of these is the closest to the 80th percentile? And that's it for today. So don't forget to have your notes and your guided reading notes and stuff completed. Please check Blackboard for updates, and hopefully I'll see you guys soon.